So this is exercise related to thermometers. The questions are there. The structured questions mainly. So as you can see, in the first question, figure 5.1 shows a thermocouple which is set up to measure a temperature at a point on a solar panel. So on the left hand side, we have a solar panel. So as you can see, remember the two wires which are coming out from this voltmeter or a millivoltmeter, they are made up of same material, and the wire which connect them together, that should be made up of a different material. X is a copper wire. So this is a copper wire. So X is a copper wire, then what should be Y? This should be another wire. You can select any, like it's having, and you can write any answer, any metal other than copper. If you write copper, then it will be wrong. Other than copper, iron you can mention, constant you can mention. Name the component Z. What we call this component Z, or what is the name of this component Z? This is known as the millivoltmeter. You can say millivoltmeter. Or galvanometer is also acceptable, but millivoltmeter is normally what is used. Or milliammeter is also acceptable. So the suggest a material that is iron. And name the component Z, that is, you can mention millivoltmeter, milliammeter, or galvanometer. The next part is explain how a thermocouple is used to measure a temperature. And it's of 3 marks. So basically the working of a thermocouple, so how it works. So there are two junctions which are at different temperature. One is called a hot junction, another one is a cold junction. And due to the difference in the temperature between hot and cold junction, a voltage is produced. And we know the temperature of one junction. We can use it to determine the temperature of the other junction by using the scale. So in exam, if you want to write the working of a thermocouple, so it consists of two junctions at different temperatures. Temperature of one of the junction is known, like we know the temperature of one of the junction, like by placing a melting ice or placing an object with a known temperature. The difference in the temperature produce voltage which can be used to determine the temperature of other junction. So this is how a thermocouple works. That basically what happened due to the difference in temperature of the hot, like it consists of two junctions at different temperature, and the temperature different cause or produce a voltage. And one of the junction, we know the temperature, so we can use its calibration to determine the temperature of the second junction. Is it clear, the working of a thermocouple? The next is experiment shows that the temperature of the surface depends on the type of surface. Describe the nature of a surface that will cause a temperature rise to rise most. As we know, dull and dark surfaces are good absorber. So if the surface is dull and dark, it will show a greater change in temperature as compared to shiny and smooth. So dull and dark surfaces are good absorber as compared to shiny and smooth. So the surface should be dull and dark. In question 2, the thermometer used have high sensitivity and a linear scale. What is meant by high sensitivity? So how we define the term sensitivity or high sensitivity? High sensitivity refers to a large change or a greater change in a reading for a small change in temperature. Yeah, so in terms of definition, you can say a large expansion or a large change in a reading for a small change in temperature. Or every 1 degree you can also mention. For 1 degree change in temperature, there's a greater change in amount of liquid. Explain why high sensitivity is important for this experiment or for any experiment. Why high sensitivity is important or why we prefer to use a high sensitive thermometer. When the temperature change is small or temperature difference is small, that time we prefer a thermometer to have high sensitivity. So we can determine a very small change in temperature. So normally those experiments in which the temperature change is small, we prefer to use a thermometer with a high sensitivity. Then what is meant by a linear scale? So how we define the term linear scale? The term linear scale means like equal distance between each degree on the scale of a thermometer, or equal distance between the 1 degree mark that is refers to a linear scale. In question 3, figure 5.1 shows a thermometer which is having a range from -10 to 50. What is meant by the sensitivity? So the same definition, sensitivity and linearity. So how we define the term sensitivity? It refers to a change in the length for every 1 degree change in temperature. This is about the sensitivity definition. The previous one was what is meant by high sensitivity. High sensitivity means greater change in length for every 1 degree change in temperature. But what about sensitivity? Sensitivity refers to a change in length for 1 degree change in temperature. And what about the linearity of a thermometer or a linear scale definition? Linearity or a linear scale means that like there is a equal or change in the length of a liquid which is there in a column is same for all one or for every 1 degree change in temperature. So same change in length for every 1 degree change in temperature is refers to linearity or a linear scale. So these definitions you have to learn. Another question is there related to a thermocouple. Figure 4.1 shows a simple type of a thermocouple. Remember the 2 wires. So here the cold junction, sometimes we have the 2 wires where we connect, like you can see this is a copper wire and here we have an iron wire. So the point where they connect with each other, that is a cold junction. So at this point we have a cold junction and here we have a hot junction. Now describe how a thermocouple could be used to measure a temperature of a beaker of hot water. So what we will do, because we should know the temperature of one junction and we can determine the temperature of the other junction. So first, we will place the hot junction, place the cold junction in melting ice. Why we prefer to use a melting ice? Because the temperature of the melting ice is 0, so we know that the temperature is 0 degree centigrade. So place the cold junction in melting ice. Then we will place the hot junction in a beaker. Of hot water. Then read the voltmeter reading. And use the scale. The like a comparison is there, the scale like 1 volt, how many degrees. So use the scale to determine the temperature of hot water. Is it clear? How a thermocouple can be used to determine a temperature of a hot water by. So what we did, we placed this in a melting ice, pure melting ice, so we know that's 0. Then we place in a hot junction, we read the scale here, and using the calibration, we can determine that what is the reading of the hot junction. Remember, using a voltmeter reading, we'll get a difference in the temperature. It does not give us the temperature of hot junction, it gives us difference in the temperature between hot and cold junction. But if a cold junction is at 0, then the temperature difference will be same as the temperature of hot junction. Then two situations where a thermocouple would be a good choice of thermometer to measure a temperature. Like what condition a thermocouple is good? A thermocouple is more suitable to determine the temperature of like very high temperature, if you want to determine very high temperature, or we want to determine a rapid change in temperature, or even for a remote sensing, like if you want to determine temperature for an object which is far away from us, we can also use this thermocouple. So two conditions to measure very high or low temperature. That is one. And the second one, if you want, we can also use for rapid change in temperature, because metals are good conductor as compared to liquid in a glass thermometer. So we can use it for a rapid change in temperature. Thermocouple is also suitable. Question 5, also related to a thermocouple. 3 wires are there and a meter are used to construct a thermocouple. Remember, the 2 wires which are coming out from the meter should be made up of same material, and the wire which is connecting the 2 junctions, like the position, that is made up of different material. So wire 1 and wire 2 should be made up of same material. Wire 3 is a different material. So they mentioned copper wire. One is a copper wire, another one is a constantan. Are used to construct the thermocouple. State the metal which might be used. So what metals might be used to construct this thermocouple? So if I mention copper, wire 1 is copper, then wire 2 should also be copper. And then wire 3 is constantan, which is an alloy. Or you can also select constantan first. So if you select the wire 1 as a constantan, then wire 2 should also be constantan, and the wire 3 made up of copper. So the idea is that the 2 wires which are coming out from the meter, they are made up of same material, and the other wire which is connecting the junction, that is a different material. So any combination is acceptable. State the type of the meter used. So we use a millivolt meter or milliamp meter. State one particular advantage of thermocouple of measuring a temperature. So what is the advantage? So it can measure high temperature. So it can measure a very high temperature or can measure a rapid change in temperature. Question 6, we have equal volume of the gas held at a constant pressure. A liquid is there and a solid. So we have equal amount of solid, liquid and gas. And they undergo a same change in temperature. Which substance will expand the most? Which one will show a greater change in volume or size? Solid, liquid or gas? So the most expands the most, that is a gas, because the weak intermolecular forces. And which expand the least? So solid expands the least. And why the pressure of the gas must be kept constant for this comparison? Because the volume of the gas is affected by, can be changed by the pressure. That's why the pressure must be kept constant. If we increase the pressure, the volume of the gas will decrease. If we decrease the pressure, the volume of the gas will increase. That's the reason we should keep the pressure constant on this. Figure shows an alcohol thermometer. State two properties of alcohol which make it suitable for use in thermometer. Like why we can use alcohol. Number one, it expands linearly. That is one thing. And the second thing, it can measure, like it can remain liquid over a range of a temperature, or you can also mention it is having a low freezing point. Boiling point is lower, but the freezing point is also low. So the advantage is that it can measure a very low temperature. Not very high, but it can measure low. So why we use alcohol? It can expand linearly. And the second thing, it can measure low temperature as it is having a low freezing point. Two changes to the design of a thermometer which will make it more sensitive. How we can increase the sensitivity of a thermometer? If you want to make a thermometer more sensitive, then what we should do? We should use a large bulb or we should use a thin capillary. So the large bulb and a thin bore or a capillary will make the thermometer more sensitive or increase the sensitivity of thermometer. Explain why it is advantage of a glass surrounding alcohol of a glass surrounding the alcohol in the bulb is very thin. If the glass is thin, it will be responsive or quick acting. It will make the thermometer quick acting, like it will act quickly or take less time to show a change in temperature. Then there is question 7. That's the last part for the exercise that you will solve by yourself. So these are the questions related to topic thermometer.